impacting the overall ecosystem. My name is Satyajit Sinha. I'm a principal analyst at IoT Analytics. I focus on compute, connectivity, and security from IoT, automotive, and focus on edge AI. So, if you look at the decades ago, the trend was generally the mainframe computing. Then trend changed, it come to micro mini computing, and then again cloud computing came into the picture. And then we started seeing again the trend that is coming to the edge computing. Let's take an example. Point of sales. Point of sale terminal was generally from mainframe. It happened based on IBM system 370 powered by. And then we started to see the change there again. We started to see, okay, the point of sales is coming again to the micro and mini computing. Then it went again to the cloud. And then from 2010 onwards, we started to see the trend again that it's coming to the edge computing. And now we are seeing in everywhere the POS terminals, you can tap and pay, having edge capability as well. And so, edge is back. Why? The question is why it's coming back. First, there is a huge surge of IoT devices, which building a lot of data. And that data need to be compute. Cloud is an option, but there is a requirement of latency requirement, and there's a requirement for obviously making that compute cost effective. Obviously, there are some requirements from manufacturing places for data privacy. And again, you don't need to send a lot of data to the cloud. You can compute some of them at the edge. For example, automotive, where are sensors of per auto vehicle generating terabytes of data. If you start sending all the data to compute at the cloud, who will pay for those charges of that data? And in the end, the most important is the edge AI or AI inferencing at the edge. Now, we're going to quickly talk about the IoT device which created the first inflection point that why edge is important. And which is happening around 2010, we started to see that there is a rise in IoT connection, and those devices required data need to be compute at the edge. And if you see from 2010 onwards, we are actually seeing that trend very clearly. And 2024, we finished 18.6 billion devices. In 2025, we are expecting around 21 billion devices. And again, 2030, we are expecting this to go by 40 billion connections. Now, if you see, it is based on multiple connectivity technology, not one connectivity will provide, but in the end, all the data generating from these devices need to compute. And yes, cloud will exist, but there is a requirement for urgency, hence it will need to compute at edge. Another topic point was cost effectiveness. One of the things that we are seeing in the trend in the market is that compute is going up. So the compute capability is going up from chipset point of view. But at the same time, the per compute cost is going down for CPU and GPU both. So what is making possible that the computation that required higher computing power and higher cost is now coming down to the chipset level, where you are paying less amount for per compute in your edge devices. And this trend that we are seeing, it has a curve for 2.5 years generally. Every time it changes, but this is what we are seeing in the CPU and GPU. And I think definitely we will see this in NPU as well going forward. Now, what is edge and where it is? Is it one device or multiple device? For that, in IoT Analytics, we define in a way that, hey, there is a thick edge. Thick edge, it can be network base stations. You can have a model running there at the network base station, and you can call it thick edge. Then it can be on-prem data centers, like in-house data centers for factories who don't want to run their important data, computer important data in the cloud. They want to do it at the edge. Hence, so they create in-house data centers kind of thing. And again, high-end IPCs, which is kind of a server capability, but at a very high-end IPCs are also can be considered a thick edge. In thin edge is basically the area where you have a gateway or IPC, which is collecting data from multiple sensor end nodes. And then the edge is the computation happening on that gateway or IPC, or you can call it edge AI box, or what we are listening to that right now, is basically those devices, networking equipment, all. And then some of the controllers like PLC controllers or robotic controllers are also coming up as thin edge. And then micro edge, which is basically sensors. So the camera devices, which has a camera capability, but also have an edge capability, computing those images or inferencing those images. They add the devices. It's called micro edge. So this is how we define edge in three clear steps: is micro, thin, and thick. And there are multiple devices, and hence it creates multiple opportunities for multiple device vendors going forward. Now, we do this analysis called what CEO talked about. And in this analysis, what we do is we take a keyword from earnings calls, from multiple earnings calls. We say 110,000 earnings calls, and we see which keywords is getting more traction in these what CEO talked about. Edge AI was very interestingly, if you see, is gained 488% growth from these earnings call compared to 1Q 2021 to 1Q 2025. And this is not a surprise. This is what we are seeing in the market, and this was expected. But to solidify this, what is happening, I can give you a quick example what has happened with the conversion of name from TinyML Foundation to Edge AI Foundation, they are also here today. And they also see the key requirement that, hey, the Edge AI term is getting a lot of traction in the market. This is how the industry is changing. It's not about any more TinyML models. It is going towards Edge AI. The naming becomes the Edge AI now. Now, we know why edge. Now we need to know why AI at the edge. And we talked about these 3 points, but we want to clarify one thing, that the data center or the cloud will exist. It's not that it will go away. Edge is coming, but it's creating a aspect where you can run AI inference models at the edge. But there will be an market opportunity for cloud as well, where generative AI services run on the cloud. With digital twin, predictive analysis, foundation models that we are seeing building on the cloud will be there. However, now the 3 aspect is requirement. If your deployment required less cost and you don't want to spend too much on something that you don't have an ROI there, definitely edge make more sense. If your requirement is lower latency, definitely edge make more sense. And obviously, when your data is, you don't want to run on the cloud, you want to run it on your private in-house data centers, definitely edge make more sense. And then you have a certain set of application that you could do on your specific edge AI devices. Now, we have, as this is an evolution of edge AI, we can quickly talk about how this evolution is evolving. So if you see, it's TinyML models, which is less than 500K. It is going towards more of a thin edge kind of model, which is less than 50 MB to 100 MB. And let you see the 3 billion parameter is also coming between thin edge to thick edge now. And in thick edge, if you see, it is going 3 to 100 billion parameter models and multimodal and multiple LLM models. I'm going to give you a quick example. So when we say edge AI, it's not about GPU or NPU. The CPU will also play a very key part. If you see the NXP, ST Micro, these companies will also play a very key part where you don't require too much higher models to run. Specifically IoT, low power devices will require this kind of CPU which can run the low power AI models. Then you have something called CPU plus NPU combination, where you are using CPU but NPU from ARM, which is Ethos NPU, which is also very low end. It's not very high end of it, because still we are talking about micro edge. But if you move to quickly the thin edge, you have a NXP with Kinara 40 tops. Again, it's have a higher capability. If you go to the at the much higher level, you have a QuickTel, which is using Qualcomm chipsets, which has CPU, integrated GPU, and NPU capability to running micro edge capability. At the same time, you have Intel all alone doing the same thing with 14 tops. And again, we all know in thin edge, NVIDIA Jetson is coming into the picture with about 100 tops of it. However, the interesting category is NVIDIA also in the thick edge, but the interesting category that came is Qualcomm, which is also there in micro edge, thin edge. But interestingly, thick edge, what is happening, they come up with called Cloud AI 100 NPU based, which is 400 plus tops with 2 PCI slots. I will go to that example. But if you look at this is generally how the evolution of edge AI happening. And when I say multimodal multiple LLM, and that is the devices like NVIDIA and Qualcomm, which has a separate PCI card slot, is capable of inferencing. Now, quick first trend, quickly, cellular IoT is integrating with edge AI capability, and these were the first deployments kind of where you see, and we started to see the shipment as well. We come to that, but quickly, if you see, it's all Qualcomm, Unisoc, Qualcomm, Fibocom, QuickTel, Fibocom, but have different layers of it. If it's less than 5 tops, 5 to 10 tops, and over 10 tops capability, and these models are already shipping in industry. Quickly at the shipment number, so you will understand what is happening. If you see, this is from 1Q 2024 to 1Q 25, there is 77% year-over-year growth on AI modules, which capable of running AI inferencing. And the year-on-year basis, if you see, some of them have already started coming from 1.2% penetration to 2.3. It is very small compared to the overall cellular market, but still there is a growth that we are clearly see in the AI modules coming into the picture. And again, these modules are cellular IoT modules having AI capability with them. Now, what these modules are doing, what this AI mod, what we talked about, is basically going into these devices. Siemens devices, back off, Advantech, Eurotech, and these are basically thin edge AI devices where you are running these models. And one of the key trends that we're gonna see in the future right now is chipset agnostic. Right now, if you see, there are generally one chipset capability with these IPCs like NVIDIA, Hello, NVIDIA, Intel. We will see that these players will go to chipset agnostic, so they will apply more and more chipset companies like Qualcomm, Rockchip, and different chipset will come, and they have a multiple portfolios of these devices going forward. There's another quick trend that is happening right now is the software. Edge AI is not about just hardware, it's about software as well, hardware plus software. You need to have an edge AI software stack with them. Multiple companies are coming up with their own edge AI software stack. Simcom, Fibocom, STMicro, NXP, Infineon. And Qualcomm has its own Qualcomm AI Hub. However, they acquired Edge Impulse specifically for that software element that they required. And this is a very clear trend that you see that all the companies right now are doing to providing this set of data. Bring your own data, bring your own model, kind of say ready model available or model as a service. And this is one of the key trends that we are seeing, that is adoption in industrial world as well. So Siemens, Backoff, they are also trying to do their own edge AI stack. Quick trend, LLM inferencing at the edge. This is what we discussed about the Qualcomm A100 that we talked about. This is one. This is the Athena box that used Qualcomm to showcase that the two PCI cards slot have one card has a 275 tops capability, running multiple LLM inference model at the edge. This is, I think whoever here all know VLM, it is gaining a lot of traction, but why it is getting traction and why that is important is very important is that because it's a zero-shot capability. In machine vision applications, you need to train multiple AI models for multiple use cases. And that's a very hectic job for developers to do. If you take one of these zero-shot VLM models and fine-tune it for your specific purpose, you can deploy these kind of solutions. I can give you a quick example. So this is from Embedded World this year. I just took one of my photos and then said describe. So it described me it very clearly, but it also described me that the badge gives the surrounding of a tech event, which was, I don't think you need to train it to judge from this event that this is a tech event, and VLM able to give that context very clearly that I am standing in a tech event just based on this image. So that's one of the key trends that we are seeing in the market. And again, with VLM, there is a huge opportunity in the market. You can use surveillance technology. You don't need to use the legacy way of looking at the images and find out your person that you want to look. However, you can quickly do a natural language search. Hey, I want to look at the picture of the guy who's wearing blue blazer. I want to look at the person who is wearing black shorts. And then the AI will bring you all the images of those ones. And that's how you're using VLM technology with surveillance technology. So what are the key takeaways? Computing paradigm is shifting. Cloud to edge. Yes, edge takes many forms. It is not one device, it's multiple devices. It's micro, thin, thick. AI rapidly advancing towards edge. We are seeing the AI capability increasing, both on this direction and also on the micro, thin, and thick. Hardware vendors are not only thinking about hardware anymore. Software is an important part of edge AI, and how it integrating with hardware is very important for the deployment of edge AI. LLM and VLM coming to the edge is that we saw, and how this is developing the applications for edge AI deployments. And edge AI is the convergence of computing, connectivity, and the cognition, and that's how we see that the market is going to grow in the edge AI market. Thank you.